All right, our last example here, just to finish off the note, we now have 0.06 kilogram ball being thrown upward and struck just as it comes to rest at the top of its motion. So it's kind of like a tennis, okay? When you go to serve in tennis, throw the ball upward, comes to its maximum height and stops, and that's when you're theoretically supposed to hit it with the racket. Some of us don't have the coordination, so probably wouldn't happen that way, but in theory, that's what it looks like. Racket exerts an average horizontal force of that magnitude on the tennis ball. A, determine the speed of the ball after the collision if the force exerted is for 0.005 seconds. So what we can do here is we can calculate, we only have one formula with average force, delta T equals change in momentum. So the average force is given, so I'll substitute that information in, 4.2 times 10 exponent 2. I know the interaction time. Now, P2 minus P1, we know, and I'm going to add an extra step in here. So final velocity, momentum, subtract initial. The initial momentum, and I'll put this step in. So when you, I'll leave this for now, times 10. What I do want to show you is the second one, we have mass of tennis ball, which is right up there, so I can put that in, sorry, 0.06 kilograms. We're looking for the final velocity of the ball, minus the initial one. The mass is 0.06, but because it was thrown straight upward and it reaches rest, it's 0. So the momentum at the top of the throw is 0. So we're only looking at our final momentum here. We only have the second row that we're concerned with. So in order to find that final velocity of the ball, it's going to be our 4.2 times 10 to the power of 2 multiplied by 0.05. That's all divided by 0.06. So our final velocity of our ball, so VBF, is 35 meters per second. And we're going to say that's forward. All right, so that answers A. So B part, same question, same as part A, but now the interaction lasts a little bit longer. So the tennis coach comes to you and says, all right, what we want to do is we want to practice that follow through. Let's have that contact time a little bit longer and follow through with your stroke. So what happens? Well, when you look at that formula, the only thing that changes is the time interaction. So I'm going to cheat. I'm going to go right down to that step in the formula and say my final VBF is going to equal the 4.2 times 10 squared multiplied by, now this is going to be 0.008 instead of the 0.005 divided by 0.06. And now we get a final velocity of 56 meters per second forward. Appropriate therefore statements. So if you look at this big picture, you've gone from 0.002 seconds longer in contact, and you have increased your velocity significantly from 35 to 56. And we're only talking about a change in time. So delta T here is 0.002. So every time you can follow through or you get that longer contact, it significantly helps the velocity of your golf ball, baseball, tennis ball, whichever. So that extended contact time is definitely beneficial by the physics here. So explain the meaning and advantage to follow through in this example. Well, I just went through and chatted about it. Increased contact time. Increased contact time or an applied force results in an improved serve velocity. Okay, so what you're looking for in terms of follow through, it increases the launch velocity So what we're basically doing here, i.e. extend contact time is equal to follow through. So the next time coach is telling you you need to follow through, they want you to extend that contact time to get that particular result. So you can see when golfers follow through in their swing, it'll improve their distance. When tennis players follow through, it improves their serve velocity. Baseball, same thing too. You can get that baseball going much faster, meaning more distance. There is the homework for the momentum and impulse section. So page 218. Any problems with that, you can get help in class. You know that I'm just going to be floating around giving you a hand. And any concepts that stem from this that you want to talk about, please make sure you do ask about them in class. See you tomorrow.